All right, so we'll go ahead and get started. Hopefully you had a good time in lab yesterday. You got set up and get started. Went through the hand-in and grade process that we'll be using throughout the semester. Again, I notified anybody that didn't get that lab done because they registered late or they ran into technical issues or whatever, and we gave an extension for that one. Make sure that you're getting that done by Thursday, okay? We want to just make sure that everybody is on the same page and everybody's starting at the same location and spot. Remember that we are on YouTube and Piazza. We have a live Q&A, so if you have questions, you can post there. Otherwise, if you're in the in-person section here, go ahead and just raise your hand. You did just a basic output program yesterday with Hello World. You changed it a little bit so that you would output your name. We're going to look at the next basic step of an interactive program where it's prompting you for input, and then it's reading that input, and then it's doing something. So we're going to be doing a basic input-output program to convert miles over to kilometers. And we're going to use that as a stepping board to look at the anatomy of a basic program. We have a basic framework. We have the scaffolding of the main entry point, bringing in libraries and stuff like that. We've got input and output, prompting the user for input, reading that input from the user, and then converting it and doing a little bit of math, right? And then outputting the results, okay? I've already written the program here because I want to use that as a demonstration to show you what's going on behind the scenes. Now, what I'm about to show you is just showing you a glimpse of the details of what goes on under the hood. You're not actually going to use this stuff when you actually compile, because to compile this, all you did yesterday in your lab was GCC, and the name of this file is called miles2kms, right? Miles2kms. Remember that tab trick, right? All I did was type mi, tab, and it completed it for me, so I don't always have to type everything, right? And when I do that, then it immediately produces this a.out file that you can run, and it prompts you, please enter the miles. So what's 150.1 miles? Well, that looks like 241 kilometers, all right? So that's how the program is working. We'll get into the details of the program here in a second. But what I wanted to show you is that GCC command is actually doing a whole series of things. What it's doing is it's taking, first of all, there's a preprocessor that goes through your code and cuts and pastes stuff and rearranges stuff. Then there's a compiler that compiles it to what's called assembly code. And that assembly code is then linked in with other assembly code or machine code. And then finally it produces machine code that then produces that's linked in with all those external libraries and finally produces an executable file, a.out. I want to show you at least a few of those steps. The first step that I want to show you is the assembly process. So I'm going to give GCC a flag here. This is hyphen and then S. That's just telling GCC, don't compile this into an a.out file. Compile this file into assembly code, right? And that produces a file called miles2kms.s. Let's take a look at what the inside of that file is, right? First of all, let's note here, right? We've got some comments and stuff in here, but ultimately this is somewhat readable, right? If I didn't tell you what this program was, you could like read through line by line and kind of get a sense of what it was for or what the purpose is, because it prompts for miles, then it multiplies kilometers per mile by miles to get KMS, and then it prints out this message. You could probably guess that it was converting miles to kilometers, either from the name, from the documentation, or maybe from looking at the line, looking at it from line by line. If I just gave you this, is it all apparent what it's doing? No. So this is not plain English. This is not natural language, stuff that we speak every day, right? But it's as close as we can get, right? It's a high-level programming language. Lower-level programming language, like assembly, is something that when it's assembled into actual machine code, are commands that a processor can actually do. For example, I don't know, is there a move here? Yeah, move L or move Q. What those are doing is move the contents in this computer register from this register over to that register. Compare the contents in that register at that memory location to the contents in this memory location, and if this is greater, then jump to memory location 5, right? That kind of really low-level stuff, that's assembly. Now, some people do write in that. Some people have to write in that. Eventually, you will get experience writing that when you do some assembly code in like computer architecture or something like that. Thankfully, we don't have to do that. We can still stay not perfect English or perfect natural language up here, but somewhere close to it. Right? What is completely unreadable is if you take this assembly code and finally translate it into machine code. And to do that, I can tell the GCC compiler to -c compile it, but don't link it in. Don't produce an a.out file. Right? And when I do that, I see that there's this other file called miles2kms.o. That's an object file. Right? Let's try to open it up and look at the contents. First of all, it's going to complain. Nope, that's not text. You can't open that up in a text editor. Right? Why? Because it's binary. Binary is a bunch of zeros and ones, right? It's not something that we as humans are intended to read or can read. It's something that the computer does understand, though, because the computer is just a bunch of electronics. It's a bunch of zeros and ones. If I tried to list the contents of that file here at the command line, it's going to complain about the same thing. It's not a text file. What I have to do is I have to use a utility called Hexdump. And this flag, don't worry about the flag here. miles2km.o, and that'll actually dump what the binary is in to the command line here, right? It's a bunch of zeros and ones along with a bunch of letters here. That's hexadecimal. That's why it's called Hexdump, right? So binary is zeros and ones, a base 2 system. We are humans with 10 fingers and 10 toes. Our base system is base 10, right? That's why it's called decimal, right? Hexadecimal is base 16, so 0 through 9, the traditional 0 through 9, but then they add in A, B, C, D, E, F, right, as their counting system. And that's what it looks like, right? Now, some of that stuff is still very much readable. Printf, scanf, hey, those look recognizable because they were in the original code, but for the most part, it's all garbage. Right? It's all garbage to us. It's not garbage to the computer, right? There's still yet another step here. Because it's not an executable program. If I tried to run that, miles2kms.o, it's not a runnable file, permission denied. That's because we've got other libraries here, right? We've got the standard input-output library and the standard library, and if we were doing math, the math library and a bunch of other things. All those libraries have to be brought together and linked together to finally produce this a.out file. So there are some additional steps that I'm not even showing you here, and there's also additional steps that we're not even talking about. For example, preprocessor directives that we'll talk about momentarily. There's also optimization. Good compilers will go through your code and say, well, that's inefficient. I'm going to rearrange it so it does the exact same thing, but it does it a lot more efficiently with fewer lines of assembly. Or I'll replace that plus operation, that multiplication operation, with an iterated addition operation or something like that, just to make it faster. Right? That's called optimization, and you let the compiler take care of it because that's its job. Right? As far as we're concerned, all that really matters is, for now, is compiling that file, miles to kilometers, with one command. That one command does that entire series of commands and more all in one shot and gets the job done. And that gives us an a.out file in which we can run, right? Please enter miles. 10. I wonder, is that going to work? Is TEN a number? Not in the traditional sense, right? But it still ran, right? Okay. Well, 10 miles, 10.0 miles is going to be 16 kilometers, right? Let's run it again, and let's give it something negative, right? Negative 10 miles. Does that make sense? Maybe not. Maybe. It depends on the application, right? I can walk forward 10 miles, but then I can also walk backwards 10 miles. Is that a negative 10 miles? I don't know, right? Maybe distance is never negative, right? Maybe relative distance is negative. What's our application? Well, we're getting too complicated for just this program, right? Those are big questions that go beyond the scope of what we're trying to do here. But they're questions that should always be in the back of your mind when you're designing something, right? What am I designing this for? oh, it's just a stupid demonstration program. Well, then those questions aren't that important. Oh, it's a program that is landing a Mars rover and has cost us $300 million so far, right? And converting from miles to kilometers per second ends up being a small little bug that crashes the entire Mars rover into the surface of Mars and wastes our 300 million, I think it was $160 million or something like that, because one subsystem was doing miles, one subsystem was doing kilometers, right? And they didn't convert between them, right? That actually happened, right, in the 90s, right? And far worse bugs have happened. Being off by a decimal point, giving somebody more medication than they should, killing them, right? Stuff like that. So those questions should always be in the back of your mind of what am I doing and what am I doing it for? By the way, this will just convert it to negative 16 kilometers, right? Big deal. Although if it was a big deal and that was invalid input, we need to make sure that we're designing it so that we prevent that, right? Prevent that Mars rover crashing into the surface of Mars. Right? Okay, so that was the really quick demonstration of the compiling, programming, compiling, and running process. Again, you're not going to use those commands on a daily basis. When we get to modular programming, you will have need of some of those commands. That's when we'll revisit those. What I want to do now, though, is I want to start reading this program top to bottom and identifying the main or the major elements of the program. We'll start up here at the top. By the way, programs are written top to bottom, left to right, because that's how English works. Right? That's sequential control flow. If you've got command, 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 that's the order that they go in, at least for simple programming like this. You can get into more complex paradigms where you've got event-based programming. You've got multi-threaded programming, and then things are non-deterministic anymore. This thread goes off and independently runs. That one goes off and independently runs, and things can be happening all over the place, and it's no longer linear control flow. But we're going to start with linear control flow here. Command A, Command B, Command C. Those are going to be that's the order that you read them in. That's the order that they're executed in, one after the other. This is not really a command. What is this thing right here? Yeah, it's a comment. In fact, it's a multi-line comment, right? It spans from line 1 all the way down to line 6. The syntax for doing that is / // Which one is that? Leaning forward, so therefore / / and then */. Anything in between those is completely ignored by the compiler. In fact, it's not even preserved by the compiler. It'll just throw it out. It'll go through, cut, paste, cut and remove any comments like this. Right? Now I have ** here because this is a doc-style comment. Right? Doc-style comments, you should just get into the habit of using them for, at least for now, for your author header here. What I have is who wrote this, when did we write it, and what does it do, right? Those three things that belong up at the header of a 5-paragraph essay in your English class or something like that. Same thing to start out with here. When we say documentation, that's what we mean. We want to see an author documentation, okay? When we get into more complex code requires more complex documentation, and we'll cover that as we go along. If I jump ahead here, I also see other things that look like comments because they're grayed out, right? The color coding here gives you a hint as to what this is. By the way, spacing is important sometimes it's not. Is spacing important there? According to the color, what just happened? Everything became a comment because I have a / space, or sorry, * space / right? Instead of the proper */. Right? If I don't have an opening one, that's also, I mean, the color coding here can't figure it out, but that's also going to be an issue. Let's try to compile that. It's already, everything's auto-saved. Let's just go ahead and try to compile that again. Whoa. There were errors upon errors upon errors upon errors. Why? Because the very first line was an error. First line being an error forces all the other 2 dozen or so lines to be an error as well. Right? So when you see an error from the compiler, go to the first one. Fix the first one first, right? Go in order. It's telling me that there's something wrong on line 2 at character 10, right? And that's just an artifact of the fact that I didn't open this multi-line comment here, right? Now that is a multi-line comment. That's a doc-style comment, right? We've also got this vertical line of stars. That's just it's ASCII art, basically. It is offsetting this and showing you that this is all part of the same thing. You can get clever, you can get artistic in your organization if you want. Just keep it simple like that. Right? You need an author name, a date, and a purpose. Right? If you're working with a partner, we need to see 2 authors there. Right? Okay, so those are comments. What's the purpose of comments? What have we seen so far? I mean, how would you characterize that comment? What was the comment again? This program converts miles to kilometers. Is that a directive to a machine? If that was a directive to a machine, we live in the Star Trek world where we can tell the computer exactly what we want it to do in natural language and not have to program at all. We're not there. So, what is the purpose of a comment? It's to communicate to other humans. Other humans being other developers, and other humans being yourself. Right? 3 months from now, you write some code. 3 months from now, you forget all about it because you wrote it 3 months ago. It worked. It passed all your tests. You go back to that code and you start looking at it like, what the hell did I write here? Right? You're going to get lost in that code unless you documented it as a future message to yourself. Right? That day you were thinking something and, oh, I had to fix this bug because of this weird situation. Then 3 months later, you forgot about that weird situation. You go back to it. Why did I do it this way? I'll revert it back to something that makes more sense to me 3 months from now, breaking it again, causing that bug again. Document it. Why did you do it this way? Right? Comments are human-readable messages embedded in code. They're ignored by the compiler, as we already said. In fact, they're thrown out entirely, ignored by the compiler. They do not affect efficiency. So if you have 1,000 comments or 1,000 lines of comments versus 10 lines of comments, that's not going to matter. You can have too many comments, but and we'll talk about that in a second here. Let me go ahead and give myself some more room so that it always pops to the top. There we go. You can have single line comments. Right? And we had just started looking at those. Right? How is a single line comment done? // Anything after that is completely ignored. You can have code, and then after that code, you can have comment after. Right? Wherever you start with that // everything all the way to the end of the line is ignored and thrown out. Right? Of course, if you put it at the beginning, then what happens? Your code goes away. Right? Here's another trick. Hopefully it works in VS Code. Okay, oops. Let me go ahead and... I'm doing poor man's debugging because we haven't gotten to module 8 where we do proper debugging. So I'm just going, I want to get rid of all this, but I don't want to delete it because I don't want to retype it again. I just want to comment it out and see what the program would do if I didn't have this chunk of code here. Ooh, magic. Right? I highlighted an entire region of code, and then I did a quick key. On a Mac, it's going to be command / corresponding to the / in a comment, and you can uncomment, recomment an entire block of code here. For Windows users, I'm assuming that it's going to be control /. Thank you for confirmation. There we go. All right. So you can have single line comments. You can have multiple line comments. Right? They begin with a /* end with a */. Right? And you can have whatever you want in between. You can have doc-style comments. Right? These are just a regular multi-line comment with an extra star, extra vertical line of stars, right? And anything that you put in there is treated as a block of comments. We call them doc-style comments because we won't get into it in this class, but what you can do is you can put really sophisticated stuff inside those doc-style comments, and then you can run a document. Then you can run a tool that will go through, grab all that stuff, and then generate readable documentation as a website, as a web page, or readable documentation as a PDF that you can print out and hand out if you want to, right? There are tools out there that can process doc-style comments and do a lot of stuff for you, right? And that's why you should get into the habit of writing them. We're not going to require that you write them for this course. Right? It's just a good habit to get into. Right? So again, what is the purpose of comments? Comments, especially documentation, is intended to tell the user, that is other programmers and the future you, right? The why and the how of the code, not the what. Right? So what do I mean by that? The why. Why did you do it this way? Well, we did it this way because you've got some complex piece of code that does some numerical interpolation that you learned from calculus that uses a Taylor series because it has a nice convergence property, right? Blah, 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 technical babble, right? You document that. We did this because it has a nice convergence property. See this Wikipedia article on why you want to do it this way, right? That's good documentation of telling you why you did that, right? The how of what you did, right? We're using Taylor series for this this computation of a square root function or something, right? What it should not do is tell you the what. And what I mean by that is you can go way overboard. We haven't gotten to this line yet, but you can guess that I'm declaring variables here. There are two variables, one of them called miles and one of them called KMS. What if I put that into declare your variables? Variables, ... Prompt the user for input. Read the input. Compute the number of kilometers. In other words, I am documenting every single line of code. That's going overboard. That's telling the what. Don't do that. In fact, these two comments on line 16 and 19 are not necessary, and they're in fact not preferred to have them there. The only reason that I have them there in this demonstration is so that I can show you what a single line comment looks like. After your first couple of weeks, code should be self-documenting, meaning that after your first couple of weeks, you're going to know what the printf function does. What does it do? It prints something to the standard output. You don't have to put in documentation, prints, please enter miles to the standard output. Right? That's a stupid, superfluous comment. Don't do it. Get rid of those comments. Right? I'm going to leave those comments in here because, again, I want to show the syntax and what it looks like. There we go. Undo, undo, undo. Right? We call that cruft. So the term cruft, C-R-U-F-T, comes from, I think it's either Harvard or Stanford or something. The story goes that there was this building there that wasn't used for anything. It was old, and they didn't hold classes there. There were no offices there. It hadn't been renovated. So what people did is anytime they had a broken projector, or anytime that they had some equipment that was broken, obsolete, whatever, they needed to get rid of it. Well, it's going to cost a lot of money to get rid of it properly or whatever. We'll just put it in Cruft Hall. Eventually, it filled up with garbage, right? And that's where the term cruft comes from. It's just a building full of garbage. Don't make your code a building full of garbage code. Get rid of your cruft, right? Anything that doesn't belong there should not be there, right? You could have some debugging statement, printf debugging here, ... right? Eventually, you're gonna learn proper debugging. This is poor man's debugging because you can't afford a real debugger, right? And okay, well now I'm done with my program. I'll go ahead and comment that out so that it doesn't actually print, but I leave the code in there, right? That's cruft. Get rid of it. Clean up your building, right? Don't leave stuff like that. Okay? Don't have comments tell the what. Don't have superfluous code in there. Okay? Code instead should be self-documenting. Anybody who is competent at that language after a few, you'll be competent after just a few weeks in the basics, should be able to look at that one line of code there, that printf please enter miles, and they know what it does. It prints please enter miles to the standard output. It's self-documenting. It's self-evident. Don't have comments like that. Right? All right, what's next? Let's go back up here. What are those things? What am I doing there? stdlib. Okay. stdio. What is lib short for, do you think? Library. So then, therefore, what is std short for? Standard. Standard library and standard IO, what is that for? Input, output. You don't start from scratch, right? You always have some scaffolding built into the language, some standard library functionality for you. Imagine if you did have to write your own printf function. Right? Every time you started a program, you would have to start from scratch. You would have to write code to actually print every single little pixel on your screen or something like that. No, right? You start with some standard libraries here. The standard library provides standard definitions of variables and stuff like that. This standard library provides basics like printf and scanf, ways to do input and output. This is output, this is input. Right? Some other useful things that you might eventually want, we're not using it in this program, but right, pull up your TI-82 calculators or whatever. I was told that you don't use graphing calculators in calc anymore. Is that right? All right, you use apps or something. Well, are you allowed phones on your exams? No? Okay, so then you're using an app for homework and then have to just do it on your own when you get to the exam? Oh, okay, all right. Good luck. Right, we bring in our math library here because I don't know how to compute a tangent. I don't know how to compute a sine or a square root or something like that, right? But all that stuff is in the math library, right? If you pulled out your calculator and you hid the sine of 2, right, or sine of pi or whatever it is, right? Did you ever wonder how it computes that thing? No, you don't care. It's in the library, right? So the math library is going to be very, very useful for you coming up as well. I'm just going to leave that out here because I just mentioned that as another option, okay? Those are actually called preprocessor directives, okay? This is from a technical point of view. Before your code actually gets compiled, this thing called a preprocessor goes in and looks at various things and makes changes. It says, oh, you want the input-output library? Okay, I'll go ahead and grab the input-output library, cut and paste it there for you. You want the standard library? I'll go out and find it, cut and paste it for you. Right? The other third preprocessor directive that I have here is KMS per mile. And then I've got it defined as 1.60934. Right? What that's doing is it's defining this thing to be that thing. So the preprocessor, before it compiles, it goes through your program and finds any instance of KMS per mile, and it does a cut and paste. Replaces it with that number there, so that when you compute kilometers, it's kilometers times 1.6 times 10 miles. Right? Imagine if we didn't have that, though. Let me restore that. Now, ignore everything that you've seen up to this point and put it out of your mind that we're converting miles to kilometers. In fact, ignore everything but that number. Right? If I were to come in here 20 minutes ago or 30 minutes ago and just gave you that number and told you that's a super important number, right? Would you know what the hell that number is about? No, right? That's called a magic number, right? It has no context. We don't know what it is. We don't like that because it's not readable. Anything that's not readable is not maintainable code. But KMS per mile, that's readable, right? Do you have to know the details of how many kilometers there are in a mile or miles in a kilometer? No. You have a nice human readable label so you don't have to have that cognitive load thinking about 1.6, 1.6, 1.6 all the time. Right? Now, there are certain things that have a context. For example, if I wrote out m_pi, what do you think that might be? It's pi. What is pi? 3.14159, et cetera, et cetera, et cetera, et cetera, right? Now, if I just wrote 3.14159, you'd probably guess, and correctly, that that would be pi, right? But you still only want to use a macro for this, a definition for this. Why? What if you're using pi in 50 different places? If you always use the number 3.14159, in some places, you might be using that number that I just said. In other places, you might get lazy and just put 3.14. In other places, you might mash the keyboard a little bit and screw it up and have 3.41, right? Not a good situation. If you're using it in 50 different places, consolidate it down to one definition and one definition only. This syntax is simply saying, define KMS per mile to be this thing right here. Yeah, go ahead. Good question. Preprocessor directives are kind of a unique to C kind of thing. After the preprocessor is done, all memory of KMS per mile is gone. But if you had a variable named KMS per mile and it was somewhere global or something like that, then you would retain that variable name. So if you're doing debugging, you would have an argument for not doing something like this. But this is the way, the way. This is the way in C of doing something like this. I'd have to dig a little bit further on justifications for why we would want to do one or the other. I'm sure that it's going to be highly situationally dependent. All right. In fact, that mpi that I put up here, that is defined in the math library. And so if you do ever have need of using pi, use the one in the math library, because it's probably going to be far more precise for that machine than you could write your own pi. It's going to be way better than 3.14. I can guarantee you that. Right? But again, all this is doing is it's going through your program, and anytime it sees KMS per mile, it switches it out with this thing. Right? So the include what we've just seen is include brings in external or standard libraries, right? So that you don't have to code from scratch. Libraries. Right? We don't care about spelling too much, right? Because we live in 2022 where we all use our spell checkers. Right? I don't have a spell checker here, but defines what's called an alias that can be used to replace magic numbers. We don't like magic numbers because they're mysterious. We don't know where they came from. We don't know where they're going. But if I have one label, we do know everything. And in fact, if I want to add some precision here, I don't know what the actual number is, but if I wanted to add precision, all I have to do is change it in one spot. I don't have to change it in the 50 spots that I actually use that number somewhere, right? Let's see, right? You can replace magic numbers with human readable text, right? And one change. Only one change, I should say. Only one change is necessary instead of multiple changes. Right? Okay? Those are preprocessor directives. There are other preprocessor directives. We're not getting into... I mean, we'd have to spend like 2 or 3 weeks on preprocessor directives if we wanted to cover them all. They do various things. There are pragmas. There are... conditionally compiling things, stuff like that, include guards. Don't worry about any of that stuff. In fact, the only ones that you're probably going to want to worry about are includes. Right? Defines maybe sometime if it's appropriate. Okay. What else do you see next? After that, line 12. Main. So there's some gobbledygook there too. Int is short for integer. We'll get to it in a moment. Int argc, char star star, argv, code magic for now. Ignore it, right? What I want you to focus on is this main, right? Every program has to begin somewhere, right? Every program has to start somewhere. And for the vast majority of programming, in fact, I don't know of any other programming languages that don't define a main. Every programming language is going to have a starting point for a program. And it's usually labeled main. That's where your program starts. Everything inside this curly bracket down to this bracket is your program for now, right? Everything in there is the program. That's where it starts executing. It starts executing on line 13, which is empty, so it doesn't do anything. Line 14, it declares variables, 17, 20, 22, et cetera, et cetera, et cetera. It's linear control flow. But where do you start? You start at the main, okay? Again, for now, ignore argv, argc. If you want to know, have a preview of what they are, they're command line arguments. We'll do that by the end of this module. But command line arguments allow you to do non-interactive input. So when I ran that program, it prompted me for input. I mashed my keyboard, and it got the input. What you can do instead is you can run the program and immediately provide it the input without having to mash your keyboard and have that back and forth. We'll talk about it later. Yeah. Good question. Probably because you've been reading Xi books and they do a very bad practice of doing something like that. Right? Be consistent. I'm always going to be use int as the return type here. Don't worry about it. Down here. If you did void, it would start complaining about this, right? And so that gets into something called the system exit codes, which we won't get into just yet. Right? But for your programs, it's enough to just cut paste this every single time. Right? Ignore Xi books when they do void main like this. Right? That's only for very, very simple exercises. Okay. All right. You will find also. I mean, I do know who the author of Xi books is. I've met him, and I don't know if he were here, he might be arguing a different thing. Nothing is sacrosanct, right? Everybody's going to have an opinion on what's the proper way of doing one thing, what's the proper way of doing another. For the most part, all of our rubric items are objective. All right, we're not going to, if you did void main, we're not going to dock you as long as it still works, right? But you should follow a consistent style. The documentation style, or the indentation style, we'll talk about that later. If you use space versus if you use tab versus you use 3 spaces, who cares? As long as you're consistent about it, right? Everybody's going to have a different opinion. That's why we have 500 different programming languages. How does a programming language born? Somebody uses a programming language, decides they don't like doing it that way. I'm going to make my own damn programming language, right? And now you've got 501 programming languages, right? Repeat for the next 1,000 years, right? All right, so those are magic for now. Go ahead and ignore them, right? What else do you see before we get into the, just overall here? I see kind of punctuation, commas. Commas separate what in English? I want ice cream, cake, and milk and pickles and crust. Lists, right? So if I'm going to create multiple variables, I can do that if on multiple lines, or they're the same type of variable. Save some space, save some typing, and just have a list of variables here, right? What other kind of punctuation do you see here? Semicolon, right? When you're writing English, what's at the end of every sentence? Period. Why? That's the way it is, all right? Sometimes there's an exclamation point, sometimes there's a question mark. But why do we write that in English? So that it's easier to read. Here's a sentence, here's an idea, done. Here's the next idea, done. Here's the next idea, right? You just never think about it after you've learned that that's the way to do it because it's so natural, right? It lends itself to easily reading things. Likewise, it's easier for a compiler to determine this is an executable statement. There's the end of the executable statement. There's the next executable statement. That's the end of the executable statement. If you have a way to end it, right? And we don't use periods here because periods are used for something else. Instead, we use the semicolon. Right? So semicolons, commas, delimit lists of things, right? Semicolons, colons, end the end, or terminate, I should say, terminate the end of any executable statement, right? They don't end every line, right? Line 12, that's not ended by a semicolon, is it? No. That's not ended by a semicolon, right? Because those aren't executable statements. An executable statement is something that does something. These are statements to the preprocessor directive, not to your programmer, not to your program, right? This is not an executable statement because it's a declaration of this is the main, right? This is not execute the main. It's just saying that this is the main, right? But these are executable statements. Create these two variables for me. Print out this message for me. Read in some input for me, right? Those are all executions that require a semicolon. If you forget a semicolon, oops. Oh, good. I accidentally killed my terminal. How do I fix it? Menu, terminal, new terminal. And unfortunately, it takes me back to where the beginning, so I need to go into lectures, yes, wherever you were working before. Right? So let me go ahead and try to compile that now, having screwed up and left off that first semicolon. There are lots of errors. There are at least 3 or 4 errors here, but that's only because, in fact, it's telling me that the error is on line 17. It's not. It happened before that. I forgot my semicolon here, and it thinks that this entire thing is an executable statement because I didn't say that this executable statement ends here. Right? It's like forgetting a period in a sentence. What does that do? Now this sentence and this sentence are the same sentence. Then it doesn't make any sense anymore. Right? Likewise, I mean, you could probably read that and still make sense of it because we're smart humans. This is a dumb computer. This is a dumb compiler. It can't recover from something like that. All right, so semicolons and executable statements. If you have multiple paragraphs in your English paper, what do we call that? I screwed up. If you have multiple sentences in your essay, what do we call that? Paragraph. Paragraphs then form the essay. Sorry, I screwed that up. All right, blocks of code, likewise, are terminated with an opening curly bracket and a closing curly bracket. With a paragraph, how do we say that these sentences form a similar idea, and so therefore they're all the same thing? We indent, and then we indent to the next paragraph. Or some people like having some space between them, right? So code, the way that we do that in code is by having an opening curly bracket and a closing curly bracket. From line 12 down to line 27. All those pieces of code is one chunk of code, one block of code. We call that block of code. Right? Blocks of code are denoted using opening and closing curly brackets. Those are your paragraphs. Right? In general, white space doesn't matter. Right? White space matters in your English essay. Why? It's got to be 5 pages. What do? You double space it. And maybe you make it 1.15 spacing so that it looks like double spacing, but you just got a few more lines out of it to hit that mark, right? All those tricks like that. Generally, white space doesn't matter here. I have kind of double spaced it here. It depends on the code, right? That wasn't necessary, right? I could have written it like this. Right? Don't follow the rule that everything should always be double spaced or triple spaced or something like that. Let's look at some alternatives here. That's going a little bit too far, right? Now everything is just one big giant block, right? Let's separate those things out a little bit. Variable declarations. Maybe I could put that print and scan because it's asking for input and you're giving input. Asking for input, those kind of go together. So you could put those into one. Maybe I want to separate out the actual math here with this thing over here. It all depends on what your code looks like and what your code is doing. If you've got a chunk of code where these 5 lines are so related, I'm going to go ahead and put them together with no spacing between them whatsoever. Because I want to, when you read it, you want to read these 5 lines together. That's one chunk. Then you have a space, or you have a blank line. And these 3 lines of code go together. And then you have a blank line. And this one line of code, well, it's kind of off by its own, so I'm just going to leave it by itself and then put a blank line after that. It's more of an art and less of a science, right? I can't give you a hard and fast rule of what good code looks like because now you're getting into a little bit of subjectivity and aesthetics. Right? There are style guides, of course. For example, let me undo all that and go back to the beginning. Right? There we go. For example, what do you notice about lines 14 through 26? As far as the white space, the leading white space. It's indented, and It's all indented at the same space, right? It all lines up nicely. What if I didn't have that? Well, I can't do that, but what if I had it like this and, whoa, I just mashed the keyboard there and indented that way over there. I did that, and by the way, white space doesn't matter, so you can put those two lines in the same line. Is that readable anymore? Nope, right? That's bad style. Right? That's clearly bad style. But now, using 2 spaces versus 3 spaces versus 4 spaces, who cares, right? Using tabs instead of spaces, 2 tabs instead of spaces, right? Who cares? As long as you're consistent about it. You want to do this for the same reason you have bullet-pointed lists. Think of this as a bullet-pointed list. List item 1, 2, 3. How are they aligned? All those bullet points are at the same vertical line. Now we've got a sublist. What did we do? We indented one, right? And all the sublist things are at the same indentation. It makes it into a nice, pretty, easily readable list. I have, this is beyond undo here, right? A style, miles 2 kilometers, .c. Oh, come on, really? Yeah, you didn't format it. Fix it. I want you to fix it. Let's open it and maybe open it up again. There we go. It just, it hiccuped there. It fixed it automatically. Whoa. So what is that tool that I just used? A style, right? You should get in the habit of writing nice, clean, well-formatted code up front. But if you ever get into a situation where you've screwed it up beyond repair, there you go. A style will help you reformat it into a proper formatting. I don't know what the default is on it. I'm sure that you can configure it to do different things. Let's find out what A style. What does A stand for? I don't even remember. Multi-language indentation and reformat filler. Artistic style. There we go. Right. That's what the A stands for. It artistically styles your code into a better format. Right. Get into the habit of writing good code up front and not having to rely on a tool like this. Right? A tool like this is a last resort. If you never copy and paste code that violates academic integrity, but if you copy paste code from one ID to another ID and it all screws up or whatever, okay, I'm not going through and retabbing everything over. A style, done. Right? And you saw how I used it, right? A style, the file that you want to do it. And I think that it even kept track of the original, so you didn't lose anything, right? If I open that up, it's still my terribly formatted version. Oh, no, not that one. Where's the original? There we go. There's the original that's terrible, right? And there's the version that it fixed, right? A style. And how did I find out about A style? Man, A style. Man, I want to know all about that. No. Man is short for manual. So if you ever hear anybody dismissively say RTM, right? RTM stands for read the manual, right? And you can go man, A style, and it tells you all about it along with how to use it, right? Man, GCC. That's going to be pages and pages and pages and pages because it's way more complicated, right? That's where we'll pick it up on Friday. Right? Have fun in your hack.